is trying to get to the back. Jam is aiming for the back. And for that front to aim to that back, I know that we're going to have to find the relative velocity. And that relative velocity is basically another way of saying the range from that front to the back. So we're going to use that 150 meter per minute minus that 50 meter per minute. And basically we get 100 meters per minute. Right? And that is our relative velocity of what needs to, between those two cars, between that time there and that velocity there, that it keeps going back and back. And let's say we wanted to use the time for the jam to dissipate, right? So the time for the jam to dissipate is going to be 10 minutes. And why is it 10 minutes? And the reason why it's 10 minutes is because, let's use purple for it. Well, you have that, excuse me. We want to use that equation, V over D over T. Basically, we get D over V is equal to T. And when we do that, let's say the distance, we never said the distance, but let's say it was 1 kilometer, right? 1 kilometer away from the point, and 1 kilometer is equal to 1,000 meters. Forgot to say that, and we don't even have givens. So if that's 1,000 meters divided by that relative velocity, 100 meters per minute, you're going to get a time. Cancel out the zeros, and you get T is equal to 10 minutes. So it's going to take 10 minutes for this here, is it right here? It's going to take 10 minutes for here to start to get to here. So it takes 10 minutes for this to get to here. And at that point, it's a bit weird with that. Because that's what's fascinating about using these physics equations. You basically know how from what edge of the car gets to another. That's what I like about using this this knowledge and these physics concepts of what we're gonna do. And if you were to do the math for like let's say the cars were 10 cars per mile. Well, let's say the flow rate was 29 car per mile, right? Per minute, the flow rate. Let's say if the flow rate was that. What would that be? So the flow rate would be around, what would the, oh God, Jesus. I cannot talk today. Basically, what would the time be? And the time would be 3 hours. With a 30 kilometer distance from an initial point, away from initial. And basically, it's like a chain reaction, kind of. It as you can see, it's like a chain reaction from all those cars. It's gonna take probably you could calculate how many, like which car would get get to that final stop, which car would actually stop, but it's for another day. But that's interesting how that's how GPS used to track systems and how to calculate your distance from which one point to another. and basically a traffic flow. That's how they explain the traffic flow with that. The equation, if you were to graph this, another way to graph this would be, graph should look similarly like this. Graph should last like this, where you have your initial point, x initial, and this is basically explaining how, and you, so it's basically a position versus time graph. As you can see, there's no really no, yeah, position versus time graph. So as we are given with these, and say, and these represent what, like the cars. So this represents the cars. This is like car 1, car 2, and car 3. Oops, keep doing that. Should look like this. Make that a little bit. Let me zoom in. Maybe that'll help. Car 1, 2. Yeah, and those separate basically explains, you know, the flowing of the cars. And as you can see, they start to the graph is it looks like it's decreasing, and that makes sense. Basically, you see how the car is going to decrease because those are the cars that have to and the car at the front is going to experience the most what's it called, as you can see, the car this is going to be lower, as in like where at the rate of which distance it has to go, because this car does barely follows. The car 1 doesn't follow a distance, and car 2, car 3, car 4 is going to follow that same, but they're going to have higher because they are going at a longer distance from which to start in here, because it takes 2 seconds for reaction time. In that sense, that car 1 starts to go, then that car 2 goes, then that car 3 goes, then car 4. As you can see, that traffic jam moving through them, the paths of individual cars we had with the wave of the traffic jam moving through them. That's what this graph is explaining, and this is the dissipate. This is when the time dissipates. Sorry, I couldn't talk. God, when it dissipates. And the time did there, and we have an initial point there. So that's when the time dissipates, and as the cars keep going on and on, that graph is using that graph as in the time is decreasing. Not the time, but the position. Sorry, the position is decreasing. And yes, that is the position is decreasing from the initial point, is because, as we said, it's getting closer and closer and closer to 0 during a constant time. And we can see how the cars are reacting to those. So yeah, that's what I learned throughout this lesson. I learned that it was a lot of fun. I had a lot of fun with it. It went I discovered a lot, which was really good. I didn't know how much I could really discover with learning this, and with learning this, it opened my mind up to, you know, how physics really is, how physics really helps us in an environmental way, and helps us throughout our life with the stuff. So this here is a picture of an 11-day traffic jam. It was recorded, I believe, in, I'm not sure. Let me see what it was. That's 11-day traffic jam. It was a world record. for the longest traffic jam to be ever existed. I forgot the place. I believe it was in China. In China, I think. Yep, it was in China. A large mountain. China's inner Mongolian on the Beijing Tibet highway. So, yep, it took 11 days for that traffic to clear. And isn't that like crazy? That is ridiculous. How long it takes for that traffic to clear? 11 days? That's crazy. Yeah, so for that position or that traffic to dissipate, that jam to dissipate, it took 11 days for a time, which is ridiculous. And it was long. It was over 120 kilometers long, and involves more than 10,000 cars, which is, whew, that's crazy. And that's what they use to calculate this. They use these methods and these equations of what is what and what is before and what is after. So I hope you enjoyed this. I had fun with the kinematics, and I had fun studying this. So I hope this did good. And yeah, I'll see you later, Mr. Farron. Hope you learned something. Okay.